AI cracked an ancient language and found a detailed warning about the sky. Scientists didn't expect what came next. Deep beneath the sands of Egypt, in one of the lesser-known tombs of the Valley of the Kings, a set of carvings had baffled researchers for over a century. Unlike the familiar hieroglyphs that line the grand walls of tombs like Tutankhamun's, these markings were jagged, disorganized, and partially burned into stone. Many dismissed them as decoration or, just damage from grave robbers. But that changed when an experimental artificial intelligence was fed high-resolution 3D scans of the tomb and asked to look for patterns. What it found has really shaken the field of archaeology. The AI, built by a private tech startup working alongside a team of Egyptologists, wasn't trained on Egyptian scripts alone. It had absorbed data from thousands of ancient languages and symbologies, including lesser-known African and Near Eastern scripts. The program detected that the unusual markings in the tomb matched no known writing system, but followed consistent linguistic structures, grammar, rhythm, and spacing that suggested deliberate encoded communication. Then came the breakthrough. The AI began cross-referencing the markings with ancient astronomical calendars, phonetic sound patterns, and religious texts stored in its databank. The carvings weren't just gibberish, they were instructions. Specifically, a set of rituals involving the stars Sirius and Orion, often tied to the rebirth mythologies in Egyptian lore. But it wasn't just religious. One part described a gate to the void that opens when Sirius reaches its highest point in the sky, something that happens once a year during the dog days of summer. It didn't describe this as metaphor. The tone was honestly alarmingly technical. Even terms that had been assumed to be mythological, like the eye of the sky and the door beneath the dust, were laid out as if they were mechanisms, not metaphors. The AI's translation described devices, levers, timed rotations, reflective surfaces, almost like someone thousands of years ago was trying to explain how to operate a piece of machinery using sacred language. Egyptologists are now calling it ritual engineering. Not magic, but instructions disguised as ceremony. The site is under tight protection now. No photos, no public access. But the AI's logs remain, and what they contain hints that this may be one of the oldest examples of an ancient culture preserving technical knowledge long after forgetting what it was originally used for. It's like if someone 5,000 years from now found a smartphone manual but had no idea what a phone was, only that the instructions mattered. This discovery has already prompted similar AI models to be tested on lesser-known Egyptian tombs. If even half of what's been decoded turns out to be valid, we may need to rethink what kind of knowledge ancient civilizations actually left behind, and why they buried it so deep. When Göbekli Tepe was uncovered in the dusty hills of southeastern Turkey, archaeologists knew they had found something that didn't fit the historical timeline. Massive stone pillars arranged in circles, decorated with bizarre animal figures and symbols, built by people who, as far as textbooks went, weren't supposed to have the tools or knowledge to build at this scale. For decades, the meaning behind the carvings remained just that, a mystery, until artificial intelligence got involved. A research group recently fed ultra-high-res scans of Göbekli Tepe's carvings into a multilingual AI model trained on ancient iconography, star patterns, and early language frameworks. The results sent chills through the team. The AI didn't just see animals, it saw a message. Using statistical pattern matching and archaeoastronomical data, the AI proposed that the animals weren't just symbolic. They were constellations: the vulture, linked to Sagittarius; the scorpion, obvious, Scorpius. But more importantly, the placement of the symbols on certain pillars corresponded to positions in the night sky around 10,950 BC. That date lines up eerily well with the onset of a mysterious global cooling event scientists called the Younger Dryas. The decoded message wasn't warm or spiritual, it was a record of catastrophe. According to the AI's interpretation, the carvings were warning of something that came from above, a cluster of objects, possibly from the torrid meteor stream that struck the planet. Not myth, not legend. A stone-carved sky map that says we saw something terrible and we want you to remember. Skeptics initially dismissed the theory as a stretch, but then infrared scans revealed buried carvings not visible to the naked eye. Symbols the AI had predicted would be there, based on patterns in other carvings. And they were, exactly where the machine said they'd be. If this interpretation holds, it means Göbekli Tepe isn't just a temple. It's a data archive, not of prayers, but of planetary trauma. A message passed down not in letters, but in stars and stone. A warning, waiting 12,000 years for the right kind of intelligence, artificial as it turns out, to finally read it. What else could be hidden at other sites we thought were religious? What if ancient people were desperately trying to document something real, using the only language that could survive stone and symbol? Göbekli Tepe may be the first of many such records, if we're willing to let machines help us understand them. So, the Greek island of Patmos is, mostly famous for the Book of Revelation, supposedly written in a cave by the Apostle John, at least if you go by tradition. Over time, the site turned into a huge pilgrimage destination, and, well, all kinds of religious symbols and inscriptions built up inside those stone walls. But here's where it gets interesting. Recent scans using multispectral imaging picked up something totally unexpected. Deep beneath layers of soot and candle smoke, there was something written in a language nobody recognized. Linguists who spent years trying to crack it. Some figured it was just really messed up Greek, others thought maybe it was a monk's personal shorthand. But then, one team tried a different approach. They fed the inscription into this experimental AI built to decode extinct scripts using pattern prediction and cross-linguistic modeling. The AI didn't get any hints or background, just the raw visual data. And what came out, honestly, shocked everyone involved. The script turned out to have weird similarities to a bunch of languages, bits of Aramaic, some early Latin, even stuff that looked like Phoenician numerals. But the wildest part? The AI found repeating patterns, especially around symbols next to certain calendar dates. These weren't names or hymns, they were warnings tied to astronomical cycles. The phrase that popped up the most after dozens of translations was this: "the dark returns when the mirror turns." The AI linked that to an old model of lunar-solar alignment where rare eclipses marked times of instability, social, geological, or even atmospheric. And yeah, it gets even weirder. Turns out one part of the cave wall had been covered by a wooden panel, which was only removed during a restoration in the mid-20th century. Behind it, there was this symbol carved deep, a circle with lines shooting out, looking a lot like modern diagrams of solar flares. Now, nobody's saying the ancient monks predicted coronal mass ejections, but the AI's analysis suggests they were tracking some kind of solar pattern and thought it was important enough to carve into their sacred space. They're calling this mysterious writing the Patmos cipher now, and it's still under analysis. But what's clear is that hidden behind all those famous stories of revelation and prophecy, there might be a much more practical, technical warning, one that sat unread for centuries until a machine finally made sense of it. In the ruins of Monte Albán, way up in the Oaxacan highlands, archaeologists found thousands of glyphs carved into stone tablets. These inscriptions, made by the ancient Zapotec civilization, have confused researchers for ages. Unlike Mayan glyphs, which for the most part we've figured out, these just didn't fit any expected patterns. They weren't really pictographic, but they weren't phonetic either. They looked like language, but just didn't behave like one. That's where AI stepped in. A university team used a custom model designed to spot deep patterns in extinct languages. They weren't after a word-for-word translation. They were looking for grammar, for structure, for logic, hidden under all that visual noise. And, well, they found it. The AI uncovered a linguistic pattern so unfamiliar that some researchers, half-jokingly, called it alien. The Zapotec glyphs didn't use a linear structure like we do. Sentences looped around. Verbs seemed to change not by tense, but by symmetry. And the most surprising thing? The meaning depended on where the symbol was on the tablet, not just what the symbol was. It's like reading a sentence where the top of the page means something totally different from the bottom. This kind of blew up the old idea that ancient languages always evolved towards something like what we use now. The AI showed that the Zapotec system worked more like mathematical code than spoken language. Instead of nouns and verbs, it tracked relationships, actions and reactions, states and transitions. Almost as if it was meant to be read by a system, not a person. So the new theory is that this wasn't a spoken language at all. It was a visual system for recording data, maybe agricultural cycles, maybe trade, maybe astronomical changes, encoded in a logic that was unique to its creators. The Zapotecs weren't just carving symbols. They were, in a sense, coding. Now, several carved stones are being re-examined with this in mind. And with AI's help, whole new layers of meaning are coming to light. The question isn't just, what does this glyph mean? Anymore. It's what kind of system made this in the first place? And honestly, it might be something unlike anything we've ever seen before, ancient or modern. When the Saqqara bird was first found in 1898, in an Egyptian tomb near Saqqara, people thought it was just a wooden toy. Shaped like a bird, with straight wings and no real feather details, most folks figured it was either ceremonial or, maybe just a kid's model. Some people went way out there and said it proved the Egyptians understood flight, but with no real evidence, the artifact kind of faded into the background. That is, until AI got involved. An aerospace engineer just curious about the thing fed its measurements into an AI-powered aerodynamic simulator. The software was actually built for designing drones, not analyzing ancient relics. But when they ran the Saqqara bird's data through it, the results were, well, pretty stunning. The AI found that the model's proportions matched up closely with modern glider designs. The lift-to-weight ratio, the wing angle, even the tail structure. When you account for a missing stabilizer, everything pointed to a working glider. Not just a carved toy, a prototype. It wasn't perfect, but it was good enough that scaled three-dimensional prints made from the AI-optimized model could actually fly in wind tunnel tests. Now, that doesn't mean ancient Egyptians had gliders, but it does mean that someone understood a lot about airflow and lift, maybe from watching birds, maybe from experimenting with clay models. And here's where it gets even more interesting. AI was also used to scan other artifacts in museum storage rooms all over Cairo. One of them, never cataloged as anything special, turned out to have nearly identical geometry, a second Saqqara bird, hidden in plain sight for over 100 years. So no, this isn't proof of ancient aircraft, but it is proof that ancient people may have built objects that encoded natural principles, things we've long dismissed as just decorative. And thanks to AI, we're finally seeing those principles for what they are. Makes you wonder, right? What else is just sitting on a museum shelf waiting for someone to take a second look? The Tartaria tablets, unearthed in Romania in the 1960s, have been one of archaeology's quiet enigmas. Dated to around 5300 BC, they're these small clay pieces inscribed with symbols that honestly don't match anything from that time. No one could read them. Some folks thought they were hoaxes. Others figured they were just decorative patterns. But an AI model trained on thousands of linguistic systems told a different story. Using a blend of symbol recognition, sequence analysis, and cultural comparison, the AI started finding order in all that chaos. It noticed consistent spacing between symbols, recurring motifs, and even strange echoes of Proto-Sumerian glyphs, despite the fact that these tablets predate Sumer by centuries. The most compelling pattern? The AI found that the symbol sequences followed a data structure that's, well, remarkably similar to record-keeping systems quantity, object transaction. A pattern seen in early Mesopotamian tablets used for trade. But the Tartaria tablets are older, much older. This raised an enormous question. Were these tablets the earliest example of a written system? Not for storytelling or law, just numbers. Accounting. A system to track goods, maybe livestock or harvests. A raw, practical kind of writing, long before writing was even thought to exist. The AI also found links between these symbols and the Avincha culture that spread across the Balkans during the same period. It suggested a shared symbolic language, a kind of protocode used for trade, governance, or even astronomy. And it proposed that this wasn't just a local anomaly. It might actually be the remnant of a far older and more widespread system that vanished before history even began. For decades, the Tartaria tablets sat as fringe evidence. But now, with AI decoding what the human eye missed, they're being reconsidered as a cornerstone in the origin story of civilization itself. Not mythical, not imagined. Just quietly real, etched in clay, and finally being read. High up in the Bayan Har Mountains of China, a series of strange stone discs were allegedly discovered back in the 1930s, hidden inside caves unknown to most of the world. These discs, now called the Drapa stones, are each about a foot wide and have a precise hole in the center, almost like a vinyl record if you can picture that. What made them especially unusual were the fine spiral grooves etched into their surfaces. Early reports claimed that these grooves weren't just decorative, they were actually microscopic text. For decades, this claim was met with a lot of skepticism. There were no translations, no cultural context. And honestly, the stones themselves had mostly disappeared from public view. But recently, high-definition scans of a few surviving discs, stored quietly in lesser-known collections, were uploaded into a powerful AI language model by a cross-continental research group. The AI was trained not just on known languages, but on pattern recognition across ancient mathematical symbology, pre-linguistic symbols, and even rhythmic encoding techniques found in music. What it uncovered sent shockwaves through the team. The spiral markings weren't random. They followed a complex fractal pattern, one the AI associated with time cycles and astronomical phenomena. But it got even stranger when the AI translated certain repeated sequences as descriptors for skyboats and metal that floats above storms. These terms weren't definitive proof of anything extraterrestrial, but they were consistent. Too consistent. And they lined up with oral legends from local tribes about beings that came down from the clouds and couldn't return. Some of the decoded phrases even hinted at catastrophe, crashes, sickness, and burial in mountain caves. Of course, there's still debate over whether the Drop-A-Stones are real or just part of a legend that's grown over time. But the fact remains the AI decoded a pattern that traditional linguists had never cracked. Whether it's ancient truth or a lost myth recorded in stone, the story is there, and the AI may have just begun to read it. The Harappan civilization, or Indus Valley civilization, flourished over 4,000 years ago in what is now Pakistan and northwest India. Its cities were sophisticated, its plumbing advanced, and its trade routes vast. But one thing has always remained out of reach: its language. Thousands of small seals, tablets, and ceramic shards covered in mysterious symbols have been found. They look like writing, compact, consistent, repeated. But every attempt to decode them has failed. No Rosetta Stone, no bilingual inscriptions. For centuries, it's been one of archaeology's greatest dead ends. Recently, researchers at Stanford developed a custom AI model to tackle this script, not by guessing meanings, but by identifying structure. The machine was taught how human languages evolved from simple marking systems into full writing. It was fed images of every known Harappan inscription, then asked to compare them with thousands of known scripts. The results were stunning. The AI detected a structure similar to early Sumerian accounting tablets' repetition of symbols near images of grain, animals, or containers. This suggested that Harappan script wasn't phonetic at all. It was partly logographic and partly numeric, like early Chinese, but even more abstract. But the AI found more than just trade symbols. On a rare broken seal, it isolated a recurring symbol cluster and compared it to other regional languages. It corresponded closely to the concept of water and flow. That might not sound like much, but in the Harappan world, water was power. Rivers determined trade, crop cycles, and life itself. With these new insights, scholars now believe the Harappan script may finally be on the path to full decipherment. Not because we got lucky, but because we trained a machine to think like language evolves, not just how it looks. The AI didn't read the script in the way we read a book. It saw the system behind it, the rules, the logic, the pattern, and in doing so, it cracked the code just enough to turn guesswork into science. For centuries, the Nazca lines, massive geoglyphs etched into the desert of southern Peru, have fascinated and confused researchers. From high above, you can see massive shapes of animals, people, and geometric forms spanning hundreds of feet. But from the ground, they vanish. Their creators left no records, and their purpose has remained one of history's greatest puzzles. Now, thanks to AI-powered aerial mapping, we may be closer than ever to understanding why these shapes were made. Using data from drones, satellites, and ground-penetrating radar, a team of researchers built a detailed three-dimensional model of the entire Nazca Plateau. Into that model, they fed an AI designed to detect not just the shapes, but their orientation, frequency, and environmental relationships. The AI found something remarkable: the lines weren't random decorations or mere art. Many of them correspond with subterranean water sources. In fact, the largest ones seem to map out ancient aquifer systems. Where the lines intersect or spiral, there are often old wells or signs of irrigation tunnels buried beneath. But that wasn't all. The animal shapes, like the hummingbird, spider, and monkey, weren't just symbols. The AI linked their positions with constellations visible during key agricultural seasons. This suggests the Nazca may have used the lines as a kind of dual-purpose system, both a map of their land and a celestial calendar, guiding planting and harvests. Some of the spiral shapes even follow Fibonacci-like curves, natural growth patterns that can help estimate seasonal changes. These weren't just massive doodles in the sand, they were science, scaled up to be visible to the sky. So why make them so huge? That's the last mystery. Some believe they were meant for the gods to see. Others think hot air balloons may have existed in some form. But what's clear now, thanks to AI, is that the Nazca lines weren't aimless. They were messages carved into Earth, perfectly aligned with the sky and the needs of life below. The Phaistos disk, discovered over a century ago on the Greek island of Crete, has remained one of archaeology's most cryptic artifacts. A round clay disc just 6 inches across, it's covered in a spiraling sequence of stamped symbols. 241 total impressions made using 45 distinct pictographic signs. No other artifact like it has ever been found. Its meaning, still unsolved, until now. Using a new neural decoding system designed to handle extremely small and unique datasets, a research team at a digital heritage lab ran every high-resolution image of the disk ever recorded through the AI. The model was taught not to translate like a language app, but to think like a historian to look for recurring sequences, symbol frequency, and contextual overlap with known scripts from neighboring cultures. The breakthrough came when the AI noticed that certain symbol clusters, like a flower followed by an arching staff, appeared regularly at the start and end of sections. It proposed that these were not words but markers, chapter titles, the beginning and end of a repeated liturgical or calendar phrase. Even more intriguing, when these sections were aligned with ancient Minoan agricultural cycles, the symbols suddenly made sense. One portion seemed to correspond to grain harvest, another to lunar positioning. The AI suggested the disk may be a rotating calendar, a ritual agricultural tool, similar in function to the Antikythera mechanism, though far simpler. One of the most surprising predictions from the AI was that the disk used a form of verbal rhythm. Based on the spacing and repetition of key symbols, the disk may have been meant to be read aloud, chanted even, not just read, but performed. That theory gained traction when a musicologist ran the pattern through vocalization software. The cadence and breaks resembled ancient Cretan hymns, as preserved in oral traditions. It's possible the disk wasn't just a calendar, but a song. A spiral hymn encoded in clay and preserved across millennia. We may never get a perfect translation, but now, thanks to AI, the Phaistos disk is no longer just a pretty puzzle. It's a message with form, function, and structure, possibly the world's oldest printed text, stamped by hand and preserved through fire, silence, and finally, machine learning. That's about it. What would you like to decode using AI? Write in the comments. For more useful information, watch other videos.